so I don't even bother with it. So, yes, ma'am.
I heard something about you being on the commercial.
Yes, I have done that. Yeah, I've done that. So the last little bit I want to talk about with this in 5.6, it's what's called the discriminant. I think it's NAT, but whatever. Close enough. Horseshoes. Close only counts in horseshoes and hand grenades.
This almost only counts in horseshoes and hand grenades.
Yeah. So, yeah, some of these got mixed together. I apologize for the wrong rows. So, what happens here is that we have, like I was saying a second ago, the discriminant of the quadratic formula is this b squared minus 4ac. You okay there?
Dying.
So, apparently. So what happens with this is that it allows you to tell the type and the number of solutions that a quadratic equation can have. So if you have a b squared minus 4ac that is greater than 0, or positive, if you will, that means you'll be able to take the square root of it, because you don't have to worry about imaginary, and you will get 2 real solutions. They might be nice clean integer values, where you get your zeros at 3 and negative 6, or they could have been 2 plus or minus 3 root 4, or that's a bad example, 3 root 7, okay, where they're just crummy decimals. It was a non-factorable in their basic essence of a problem that we've worked with, but yet we can still make it work using quadratic formula and or completing the square. The other one that can happen is if your discriminant, the whole b squared minus 4ac, is 0, then you have a specific type of quadratic. You have a perfect square. This means you have one real solution. That's when you have a perfect square. For example, if you have the quantity x minus 3 quantity squared, that means it touches the x-axis at one spot, 3. The vertex is only at one spot at 3. The vertex lies on the x-axis. Whether it's up like a cup or down like a frown, just still has the dependency upon the value of a. That doesn't change it. Okay. And then lastly, if the b squared minus 4a sweep, if this is less than 0, not to be confused with the movie less than 0.
Never seen that movie, so I don't know what you're talking about.
It's an old movie. It's from the 80s. It's one of those rat pack movies. So, bless you. Then you would have, no, you still have solutions. They are 2 imaginary. You have 2 imaginary solutions. Now, think about that. It makes sense because all of our imaginary solutions happen when you have the square root, bless you, of a negative number. Yes, sir? I'm thinking about it right now.
That was supposed to be a joke, but it was really bad.
Actually, you know what? It's funny you mentioned that. You guys remember Miss Condon from Rosette?
Oh, yeah.
Okay. Miss Condon's one of her daughters goes to school at I think Aurora West. She texts me pretty regularly when she has problems with math, trying to help her out. So she texted me and said, "What's an imaginary number?" And not so many words. So I text her back, "I'm thinking about one right now." She really didn't find the humor in it, but I was laughing pretty hard. My wife goes, "What are you laughing at?" And I showed her the text. She says, "You're a nerd." So yeah, it's okay, but it's funny. Then I text her back and explained to her what imaginary number was, and then they were able to finish their homework. So
How do you explain the number?
the square root of -1, just like we did. Go back and think about how we did this. If I know that this happens,
Why'd they name it an imaginary number?
I don't know. What happens is all numbers are either prime or composite. So if you have a negative number, it's always some sort of a composite value because you can split it apart to be a -1 times anything else. So when you work with square roots, it does the same thing. You can break them into factors, but yet we break it into factors of positives so you can factor out, your perfect squares, and all you have to do is break out that -1. That's the only reason why they came up with them. That way, all the other half of numbers weren't feeling jealous. Yes, ma'am.
So if it's like when it has two real solutions, there's a graph and then there's a frosted place, and then if it's like one surface, it's like, but then how do you graph the graph?
I'm doing that right now.
This is a mixed joke.
That's not smart.
Oh, I thought you flipped me off. That was awesome. Seriously, your hand went like this real fast, and I'm like, I thought you seriously flipped me off. Oh, man. No, what?
She went like this.
It looks like that. It would look like that.
So it just doesn't.
Because like she didn't know. That's why she said that.
I know the answer to my question.
What do you have done it before?
You're on the
Yeah.
use Greek to like found them out, and then Raphael Bombelli of I don't know when because he's not important.
Dead.
Decided that he wanted to make all the equations for him. So if you ever create a time machine, destroy these two people.
Do you know Bill and Ted? We have them take care of that for us.
I'm confused. What was the question?
What? We didn't watch this and this guy was like time traveling and he got shot because he really didn't want to go
And then you said I think about it, and it was not funny.
My sister is.
Or it flew right over my head.
Yes, it's 2:30.
She was like flipping through channels.
What I want you guys to do tonight, this is, I got you guys going through 5, 6. I still want you guys to work through a couple more of these solve equations because believe me, you still need a little bit of help on them. I put it on the calendar already. It's, what did I just say, 267 I think? I think I said 267. It was 267, right? 96, sorry, 296.
When's our next quiz?
Sooner or later, I haven't figured out when. Just to the odds, you've got 5 more solve the equations, and you got 4 of them talk about discriminants. When you find the discriminant, it's a very common ACT question, believe it or not. They will ask you an equation, say, describe and tell the type, or what is the type and number of solutions that this quadratic has. And that's basically asking you, what's the discriminant and how many solutions? That's what it does. I know that when I've taught the ACT prep class, that's actually a question in the practice test. It's on a couple of them. If any of you guys are taking the practice ACT, in a couple weeks? Yeah, pretty soon coming up here. You'll probably see something like that on there. You will also, you're going to be fine. Some of the things that are going to be on the ACT, and what I want you guys to do is kind of take note of some of the math things that you have not yet seen. Logarithms, exponential functions. Some of those things are on there that you haven't gotten to yet, but I guarantee you most of those style questions is a matter of plug and chug on the calculator. If you know how to use the calculator to create logarithms, it's just a matter of putting the answers in and hitting equal, see which one works. Yes, that's the next part I was getting at. The calculator you guys have is a legal calculator for the ACT. So if you see logarithms or you see an exponential function, I think it's alpha zoom. Nope. Alpha window. Yeah. Alpha window will allow you to work with what's called a logarithm. Anybody in chemistry? You're going to be dealing with logarithms.
Oh no.
Okay. Well, you're gonna have to, then I'm gonna have to teach you guys how to use logarithms on the basic calculator because you're gonna have to know how to change your bases. This calculator would do change of base for you. The standard calculators are all in base 10, okay? So it's a very simple process, but logarithms allow you to figure out basically this question. If you know that 2 squared is how much? 4. What's 2 cubed?
8.
Then what 2 to what power is 6? That's what a logarithm allows you to do. It allows you to figure out what that exponent is to make it work. That's what they are. Okay? Yes, ma'am. Yeah.
Sarah, the string wall when you're supposed to drink like 2 bottles.
It's stuck in your head now.
Yeah, I feel like, then you don't.